All right, so you are well into minerals in lab. You folks at home, I have no way of knowing exactly where you are, but folks on campus, half of them yesterday got, if not done, well into the 20s with their minerals. By week 2 of minerals, as I promised you guys blow right through this stuff. We are going to spend one last week, okay? Monday, you guys still have, second meeting, I know that. But we're going to spend one more week after that, going to talk about mineral groups, which is something we'll touch on today. We're going to make sure you have the right answers, so on and so forth. All right. So you've been mineraling. The big difference comes in what I expect you to know for which part of class. Okay. In here, I'm never going to hold up a hunk of something and say, what is this? That's why we have lab. Similarly, in lab, I'm not going to say, well, why is orthoclase feldspar different from rose quartz? They're both made out of silica, they're both pink, but why are they different? No, that's for in here. So, and the same will be true for rocks. I'm never going to hold a piece of something up and say, what is this? But I am going to talk about it like you actually paid attention in lab, and I'm going to say basalt 500 times or granite 500 times, and I expect you to have a picture of that in your head, okay? I'm going to use it assuming you know what I'm talking about. So that's, and we talked about this in the first day of lab, how lab and lecture kind of work together at times. This next month or so is definitely one of those times. So, I know we sort of took a detour to talk about a little bit of everything about the Earth. This really kind of comes back to the atomic review, because we're going to talk about elements, and we're going to talk about compounds, and so on and so forth, because that's what minerals are. So, minerals are composed of one or more elements. One or more. We just had a question on the first test that asked you about things that are composed of 2 or more elements. Remember, I babbled something about being very similar to what we talk about. This is it. Not all minerals are compounds, is what it boils down to. You saw a couple already. Sulfur. What's sulfur made out of? Sulfur. That's it. Right? Graphite. A little more abstract, but yeah, graphite is just made out of carbon. It's always funny, you guys picked it up, you're like, oh, it's lead, I got lead all over my... Pencil lead is not lead. If it was, we'd have a lot of dead children. All right? That's just... So, it's graphite. And it's not even straight graphite, because...
So, if graphite was made out of lead, it'd be a lot heavier.
Well, there's a lot of what ifs in that scenario. But that's not even graphite. It's got to be an alloy, to borrow a term, because it's graphite, as you see, is super, super soft, right? So, anywho, we could go on and on. Diamonds are just made of carbon, all right? So, not all minerals are compounds. Many of them are, though, and you're going to see so many. We had you write down the formulas. You're never going to have to regurgitate one of those formulas to me, but we do use those, as you'll see in a little bit, to decide what group it's in. We use those formulas to categorize them. So, loosely speaking, and we don't really ever use this conversationally, but we want to set the tone, all right? All these minerals you're going to see fall into one of 2 categories. They're either compounds or they're elementals. Elemental actually stays on as a group, and all the other groups are compounds. Luckily for you guys, out of all those 100 and some odd elements that are in the periodic table, we tend to see the same ones over and over and over again. There's this wonderful list that I'll show you in a moment or two that is the 8 most commonly occurring elements in the Earth's crust, which, by the way, is different than the mantle, which, by the way, is different than the core. So I ought to make a bigger deal about that one because it's not in the Earth. It's in the Earth's crust. Not going to have you memorize all 8 of them. Don't worry. But the top 2, we're going to talk a whole lot about. And I would say, unfortunately, I'm going to make you memorize them, but we're going to use them so much that you can't help but remember them. Now, which one comes first? Maybe. You might have trouble with that. So out of those top 8, the first 2 make up nearly 75% of everything that's out there. You've heard me talk about the silicates already. Okay, that's these guys. It's oxygen and silicon. All right. Oxygen is not number 1 in the air, but it is in the air. And I find that very interesting. I've never done much with that interest, but I think it's kind of neat. We're a geology class. We round. So 47% is oxygen. You're going to see O show up in those formulas a lot. 28% is silicon. That gives you 75. Now, if you round the rest of these, we're going to end up over 100%, of course. So what else is in there? Aluminum, iron, calcium, sodium, potassium, magnesium. Now, at some point, a long time ago, I looked over the formulas that you guys are writing in your minerals. These guys are in there, but there's also some other stuff, too. And I think that's more a function of, we have to cherry pick some stuff we really want you to, they've got to look at salt. All right, sodium's in here, but chlorine, no. And like I said, a handful of other things. So they're unique for their own reasons enough that they show up, in Minerals 101, but they're not in the top 8. Going back to a conversation that we started the class with, and then something you kind of already knew. Look at all the stuff that isn't there. And going back to thinking about elementals, you had gold, silver, platinum, a whole bunch of other really rare, expensive stuff. All of it, that which includes the stuff that you don't know about, falls into 1.5%. No wonder it's so rare. No wonder it's so special. And the fact that it's prettier, that's almost secondary, okay? This stuff is rare because it's hardly there. So, and then if you go back and you think about, gold is an easy one because you can picture so many things that are gold, especially if you go back and think about ancient history and these, entire palaces and this and that's, all the gold jewelry that's out there, which, mind you, is alloyed with stuff too. It's not pure. Usually. And then you think, oh my God, that's a lot of gold. And then you think about Fort Knox. You've never seen Fort Knox, but it's supposed to be full of gold today, right? That's a lot of gold. But that isn't anywhere near all of it. And that is only a small percent of a small percent. I guess I'm trying to get you to do a little reverse engineering to say, oh my gosh, there's a lot of crap out there. And there is. There is. Which makes finding that stuff in that 1.5% that much more awe-inspiring. And that's why, there's entire fields of study dedicated to figuring out where we have a good chance of finding it. They tend to be found with other minerals. When you find that mineral, then you might find this one. And they tend to grow in veins and so on and so forth. So there's a whole science around that for a very good reason. Finding it in the beginning was just dumb luck. I assume. So silicon and oxygen, the big 2. Said this, the only thing that's new here, it isn't even new, but you're seeing it in print for the first time, is the word silicates. Okay? Silicates is that group. A group of minerals that are composed primarily out of the elements silicon and oxygen. And out of the 31 minerals you're going to learn in lab, nearly half, if not more, I forget, are silicates. So it's a good guess on that mineral practical. Not telling you how to cheat, but if you can't remember the group, what are you going to guess? Silicate. All right. Now, I don't want to see silicate. I'm just going to draw a big old red line through it because I know you didn't learn anything. Study anything, I should say. Okay, but just when in doubt, if you don't know, it's almost a 50-50 chance. There's a lot of silicates in lab. All right, narrative. Don't write it. So we spent a whole lot of time saying a mineral is this, a mineral is this, a mineral is this. There's a question on the test, and we're going to get into it right now, that asks you for the definition of the mineral. Somebody the other day was fretting a little bit that I was going to have you write stuff out because their handwriting was bad or something. There's 2 times you write, definition of a mineral and definition of a rock. If we're still on paper, you're going to squeeze it in at the bottom of that Scantron. You folks at home will have a nice block to write in. All right? But you're just going to scribble it in at the bottom. Anywho, please do not write a mineral is composed of 1 or more elements, which is what we said a couple minutes ago. That's like saying meatloaf is good. It's not saying anything, okay? It is, but when you see this next thing, that's the definition. So please, when I ask you for the definition of a mineral, and I know most of you are just writing that because you can't remember the definition, but you did manage to remember one thing about minerals, and that's they're composed of 1 or more elements. But I still think there's a handful that get confused and think that that first thing is the definition of a mineral. Now, how you write it, I don't care. You can do bullet points if you're a bullet point kind of person. You can write sentences if you're a sentence kind of person. I need to see these 4 things. And it's 4-point question. Told you I don't do partial credit. That is not true for definitions. We'll explain what each of these mean in a moment, okay? So a mineral is naturally occurring. A mineral is inorganic. A mineral is crystalline. And a mineral is composed of a fixed set of chemical and physical properties. I'm going to change the slides. I know you're still writing, but all these words are on the next slide, I promise. Whoops, except I went 2 slides. A mineral is a naturally occurring inorganic substance with a crystalline structure and a fixed set of chemical and physical properties. If that works better for your brain, God bless. Use that. If the list works better, use that. I just literally need to see those words. We good? Can I switch? And again, you're going to see them a 3rd time. So, naturally occurring, what does it mean? Well, it occurs naturally in nature. There's not too many other ways to say that. It's not man-made, woman-made, squirrel-made. It just is.
Squirrel-made.
All right? It just is. That's not to say that we can't recreate some things. We've all heard of, like lab-created sapphires and stuff like that, and diamonds and whatnot. We can recreate some things. But what we mean is nature made them. So that's what naturally occurring means. Inorganic. Not all things that are natural are organic. All right, we're not talking about the Crunchy Nutty Isle and Hannaford's or Pete's or whatever here. It means it's not a byproduct of life. It's not alive. It never was alive. It never will be alive. Now, if you've had environmental science, you know there's something wrong with that sentence. For the rest of you, I'm just trusting on blind faith here. Now, where do you think the nutrients came that go into your carrots and stuff like that, and that you take into your body? Yes, there is a way bigger cycle going on here that, again, we're not exactly ignoring, but as you kids might say it's way too meta. I don't know. Kids still say that. And at any rate, that's way, something we don't need to worry about right now. So yes, some nitrogen that we're talking about could arguably someday end up in a living organism. But just right now, this is what we mean. And this is only a problem. It's only something to discuss. It's not even a problem. It's only something to discuss because there are rocks that are organic. These are minerals, remember. There are rocks that are organic. What's an organic rock? Somebody tell us. Remind us. No, technically no.
Oh, coal.
Coal. Oh, stromatolite, that's a fossil, but sort of. Fossils are tough. We'll talk about this when we get to sedimentary rocks, why there's an issue there. But coal is what I was fishing for, okay? Coal was what in a previous life? Plants. Coal was a swamp or a marsh, okay? Directly, literally, you squish it, you dry it out, here's a hunk of coal. That's directly, and that's why you say coal is organic. There's a couple other rocks that fall into there, okay? But that's why they make a big stink about this one. And it is a tough one, for the couple of you that said the fossils thing. Well, I'll try to explain why it's not supposed to be. I may convince you, I may not. It doesn't really matter. You could argue that in your geology 300 level classes with somebody else somewhere else. So naturally occurring, it occurs naturally in nature. Inorganic means it's not a byproduct of life. Crystalline. Well, I've talked about Legos in here several times, and it's really the case again now. Okay, all solids are made of crystals, whether you can see them or not. I know when you think of crystals, you got these pretty things hanging in your window, put rainbows all over the place, or you think maybe about that crystal quartz that you saw in lab. There was a while back where everyone was wearing those on their around their necks. All right, it's not so common anymore, but you still see a few people doing that. Those are what come to mind as crystals, but there are so many things that you don't see. And this is why I use that Lego analogy thing, okay? That it's the bigger whole is made up of these crystals. And like we talk in lab, if you guys were majors, okay, we would focus so much more on the crystallography aspect of minerals. You could take an entire 14 weeks on minerals, for crying out loud. It was not my end of, I'm on a different end of geology. I did not appreciate minerals, but that's how you find out which end of something you go on when you take your major classes. You're going to specialize in something. It was one chapter in your intro book, and you're like, oh my gosh, I'm going to do 14 weeks on it. And by the end of your 14 weeks, you're like, oh wow, this is actually really cool. Okay, well, that's where you're going to maybe excel at in your field, and so on and so forth. So for minerals didn't do it for me. But it is cool if you dig the math, if you appreciate, naturally occurring intercepting angles and so on and so forth. There's a place for you, all right? But everything is made up of crystals. Fixed means unchanging or constant, static. Not fixed as in it was broken, all right? So fixed chemical and physical properties means they're always the same. And I used to say it didn't matter which one you wrote first, and I won't mark it wrong if you put physical before chemical. But in a nod to our chemistry teachers out there is an order. It is important. It's the chemistry that makes the physical, okay? You are you because of your chemistry. Your cat is your cat because of its chemistry. The tree is that tree because of its chemistry. The chemical makes the physical. I will concede that finally. All right? I think the physicists still win on whose science is more important because physics holds everything together, probably. But chemistry is right up there in the running. Geology, as you're finding out, is a little bit of all the sciences. All right? But, back to the point, that is why halite always looks like halite. That's why halite always tastes like salt. Why halite is always cubic when left to be natural, and so on and so forth. Now, if you're thinking about that bottle of pink Himalayan sea salt you just bought at TJ Maxx, or the bag of road salt that unfortunately you're going to have to drag back out. And yeah, some of these are really nasty looking and gray. Some are pretty and pink and arguably not very cubic. There's a whole lot of things going on there in processing or lack thereof, okay? And also impurities. I use a lot of baking references, especially when we get into igneous rocks, but this is a great point to start. All right, since I mentioned impurities. You've had chocolate chip cookies before in your life, right?
Yes.
Okay. Some people's chocolate chip cookies are better than other people's chocolate chip cookies, right? That's because they do a little something different. But arguably it is still a chocolate chip cookie, right? Okay, it's the same thing with salt or with anything else. And I'm trying to get you guys to see some of that inherent variation down there by switching up boxes every week. This week you had box 3, last week you had box 1. Oh crap, their rose quartz looks a lot darker than ours. It's going to happen, okay? You folks at home, I don't have as much freedom to do that for you. I try. But the good news is, again, that since I know that, I try to give you pictures for your test that look a lot like the pictures that I gave you for lab. So you do have that going for you. But here we do try to get that appreciation that even though this is very much true, the properties don't change, there's always a little something. Okay, whether it's on accident or on purpose, going back to the cookie recipe, that makes it a little different. And this, again, is narrative. You'll need to write it. But based on the chemical makeup, certain physical properties or characteristics exist, and those are unchanging because the chemical properties are unchanging. It's the same thing as going back and talking about adding protons. It just changes it. So you can't put different elements in, so on and so forth. Okay? Okay. Hasn't been a whole lot, but I'm going to stop it here, and that'll leave enough for a full lecture when we come back next week.